Alright, so we're going to start linear review, which is connected to the bigger standard of piecewise equations. Okay, so we're going to linear equation review, which is going to be very closely related to the actual Algebra 2 topic of piecewise equations. Alright, the things I expect you to remember. We have 4 formats. Equations, we've been working with those. Tables, we've been looking at tables. Word problems, we're getting there. And graphs. That means that you should be able to take a graph and get to an equation. Go from an equation to a graph, or create a table of points, or write me a sentence that describes what's happening in the graph. Okay? We have standard form. This is because in our little line mystery game, it asked you what standard form is, so I'm just going to write it down so you know what it is. Okay? AX plus BY equals C. And in this particular case, they should be not fractions, which means integers. Okay? A, B, and C. Standard form. A, B, and C. Okay. Vertical line. Horizontal line. Anyone remember what those things look like? How to write them? Nope, that's slanted. Vertical line. Yes, I heard it. Thank you. X equals C. Technically, vertical and horizontal lines are a subset of standard form because A is 1, B is 0, and C is the other number. Horizontal, like the horizon. What? You didn't?
No idea.
I know. Okay. All right, and then slope-intercept form. Slope-intercept form. Y equals mx plus b. Okay, where, yeah, that should be review. I'm not actually going to do examples with those formats of the equation because I just want to remind you that those things exist. Okay, I believe worksheet 1 does a little bit of review of slope-intercept form. Great. It is semi-useful depending upon the context. Okay, worksheet 2, that's the one that's going to actually cover the content that I need you to know. And that is not necessarily review, depending upon what you did in Algebra 1. And this is point slope form. This is the one I need you to use. This is where worksheet 2 does some practice. Okay? We call it point slope because you're going to use a point and you're going to use a slope. I know, so fancy. I'm going to give it a subscript, point, slope, any point. Any point, not specific to the y-intercept. Right? This equation is only good for one point. This equation is good for any point. That's why it's more useful. Okay? So any point and a slope. And it's going to look like this. Okay. Y minus y1 equals slope, parentheses, x minus x1. That's point slope form. This is the only one I ask my students in calculus to use. That's it. That's the only equation of the line that we use regularly. Because it is useful for all formats. You can get from here to here, or from here to here, or all the way back up to standard form. But you would never typically start in these formats listed above unless it was very, very specific and easy to start there. All right, let's go ahead and take this equation and solve it for y. I just want you to see the different formats that this could look in. We're just rearranging it a little bit. I left the blank on purpose. All I did is I added my y1 to the other side, so it's in y equals format. Okay. I'm going to rewrite it using some different letters. Yeah. Did you know that the parent function that you learned how to transform is just y equals x? They don't teach you to graph lines by transformations because you don't do transformations in Algebra 1. You just graph a line. But in Algebra 2, we have a transformational approach to graphing for all of our parent functions. There's about 8 or 9 parent functions that we cover over the course of the year. It's just a transformation. Now, when it's lined up here, the point is HK. The slope is A. So that top right example on the inverse homework that you asked me to graph, because it was in this format, same, it was left one up too. Slope of minus 1/3. Now it's a slope. We don't really stretch a line because it's really easy to count a slope. But it is easy to transform that point. Left K or left H up K. Whatever you happen to be doing. Okay? Most of the time we'll work either, right? It doesn't matter whether you leave this here or here. Just make sure you know where that coordinate is. Okay. 2 examples so that we can play? Yeah? Okay. I think I can make it work. Example. Graph y minus 3 equals 2/3 x plus 5. And we don't need a graph square. We're just going to label our points. Mostly quadrant 2, I believe. I'm going to count out to 8. Okay. And graph. What do you need for a line? Well, 2 points, or point and slope. Point, slope. Pick them out, graph it. So I see this, I'm like, okay, well, I like to see mine in a y equals format. So I'm just gonna put that plus 3 over there. So my point is left 5, up 3. It's not necessarily the center of my picture because this is a line. There is really no center. Okay, but it is left 5, 1, 2, 3, 4, 5, up 3. Negative 5, 3. And my slope is 2/3. See as how I'm not on a grid? I would at least label one other point so you know exactly where that is. especially, oh yeah, see that? I don't know what either of my intercepts are. None of them came out as integers. That's why you have point slope form, because my intercepts are not easy to use in this case. So if I go rise, run, right, I'm just labeling my other points. Rise, run, there we go. I'm not on a grid, so you know exactly where they are. I could even count the other direction, but I can tell here that my y-intercept is between 5 and 7. It even looks like it's between 6 and 7. But you are not allowed to guess. You cannot assume that's 6.5, because it's not. If I count my ratios correctly, it's 6 2/3. I think. Yeah, I think it's 6 2/3. But you have to be exact. You cannot estimate, which is why you have point slope form. Now I'm going to just highlight this dot because that's where I started the graph so that I can keep track of what I was doing. Okay, second example, write the equation. Okay, there you go. That's all I'm going to label. That's it. No grid. Write the equation of that line. If you don't know the y-intercept, you cannot use it, which means you have to do point slope form. That's why we have it. -2, 0, and 3, 1. So, point, slope, 3, 1, 1/5. Okay? Doesn't matter whether you're graphing or writing, you still need those two things. Y minus y1. Slope, x minus x1. Okay, y equals 1/5. Don't get carried away, guys. Is that y equals format? Yeah, leave it. You don't have to multiply that out. Why? Why do you need to multiply that out? The answer is not because I need to graph it. You don't need it in y equals mx plus b to graph. You just need it in point slope form to graph. This is more useful because if I try to multiply this out, I get minus 3/5 plus 1. 2/5? I don't want a y-intercept of 2/5. That's hard to graph. Don't do it. Leave it. What are the benefits to point slope form? You don't need an integer y-intercept. You're not going to have an integer y-intercept, guys. It's almost never going to happen. Yeah.
You want us to write it like that?
Totally fine. Now, the directions will be the directions. It might say, write this in slope-intercept form. But most of the time, if it does not specify, you leave it in whatever format. Now, we're about to do piecewise, right? That's like the next lesson where we're headed. We just need it in y equals format, not in any specific format. And so I would always leave it here unless for some reason I needed to also know the y-intercept.
But it has to be y equals.
Yes.
If you did it off
More than one correct equation. And so if you wanted to do y minus y1, I like both positive coordinates, it just, right, this personal preference. They're both correct. Both. I would accept any accurate answer to the equation of the line. You want to pick a third point that's not labeled? Fine. Doesn't matter as long as you do the equation. If we multiplied these out, we would get the same result. And that's what it comes out to. Okay, that is it.